again. And let me scroll this way. Where's 4.8? Should be here somewhere. Haha. Here is 4.8, y'all. Okay. In 4.8, y'all, we're going to talk about something called Lopital's rule. Lopital was a French mathematician. When was he around? I don't know. A long time ago. I had this one professor, Pan Am. He would write down the mathematician's name and he would write the year that they were born, the year that they died. He was like, yeah, he was like insanely smart with that kind of stuff. He was great. He was really good. I learned a lot from him. I don't remember some of that stuff, but I'll show you something, guys, that he taught me. I'll show it at the end of class. This is kind of a neat little trick. But that he showed us one day. I took a class with him called the history of math. Yeah, the history of math. But anywho, there you go. L'Hopital's rule, y'all, refers to limits. Okay, so we're taking limits here, y'all. We're taking limits as x approaches particular values, and what's going to end up happening in the time we use L'Hopital's rule, I should say, is when we take the limit. If the top or the bottom either goes to 0 or if the top or the bottom goes to infinity, it's hard for us to find those limits. So I want you to think about this for a second. If we were to try to find the limit here, right? What is the limit as x approaches 0 of tangent of 0 over 2x? So I'm first going to grab my calculator. And I'm going to make sure that I'm in radians. I don't know if I am mode. Yeah, I'm in radians. Okay. So the first thing I want to know is, okay, what's the tangent of 0? Well, the tangent of 0, y'all, if you notice, is still 0, right? So I'd have a 0 on the top. But think about it this way. If I were to plug in x equals 0 on the bottom, wouldn't I also have 0? Okay, this is what we call indeterminate. I can't do 0 divided by 0, okay? It just doesn't work. This is when we do L'Hopital's rule. L'Hopital's rule says we're going to take the derivative of the top and we're going to take the derivative of the bottom and then we're going to find the limit. So I'll give you a hint. The derivative of 2x is 2. That's my hint to y'all. Does anybody remember the derivative of tangent? Yeah, secant squared x. Excellent. Perfect. Good. Secant squared x, right? Right. So then now we're going to take the limit as x approaches 0. Okay. So look, on the bottom I still have 2. I'm going to grab my calculator. I want to find secant squared on my calculator. So y'all remember my calculator doesn't do this, right? I can think about this, y'all. Let me back up a little bit here. Yeah, I can think about this as 1/2 cosine squared x, right? Because secant squared is the same thing as cosine squared x. So look, let's do this. The cosine of 0 is 1, okay? So if cosine of 0 is 1, this is going to become 1 over 2 with 1 squared, which is 1/2. And there's my limit, okay? L'Hopital's rule says if you get an indeterminate form, when you try to plug in your values for the limit, then take the derivative of the top, take the derivative of the bottom, and then find your limit. I'm not using the quotient rule here, y'all. I'm not using the quotient rule where we did like the bottom times the derivative of the top. I'm not doing that. I'm just taking the derivative of the top, taking the derivative of the bottom, and then finding my limit, okay? That's how L'Hopital's rule works. So my answer for this one, y'all, would just be 1/2, okay? Yeah, coefficient, that's the number in front, yeah. That's the coefficient. The number in front of a variable is your coefficient. Yeah. So when we tried plugging in 0 from the get-go, we ended up with that indeterminate form, right? Because we ended up with like 0 over 0, right? We couldn't do it. I can't do that right there. That just doesn't work. So then we say, look, let's take the derivative of the top and the bottom, and then let's find the limit, okay? So look, y'all, we're going to do the same thing with the next one here. I'm going to show you what's going to happen. If I plug in 0 directly, the sign of 0 is 0. 7 times 0, 0. Again, that's indeterminate. I can't do it. But we can take the derivative of the top. Anybody know what's the derivative of sine of 4x?
Cosine 4x plus 4.
Not plus 4, times 4. Good. Okay. So we're taking the derivative of the top. Let's take the derivative of the bottom. Yes, ma'am. Well, okay, but why is it 4 over 7? You understand my point? Why is it 4 over 7? What's the derivative of the bottom? 7, right? Now, if I take the limit as x goes to 0, well, I know the cosine of 4 times 0, the cosine of 0 is 1 over 7, and here's my 4/7. Does that make sense? So guys, let me ask you a question. We've done 2 problems using L'Hopital's rule. Does L'Hopital's rule seem like something that's easy to do? So far, it's pretty straightforward, right? When do I use L'Hopital's rule? When I have something like that, when I have an indeterminate form, that's when I'm going to go ahead and use L'Hopital's rule, okay?
Wait, so on the stuff we were doing in like 4.0, like chapter 4,
Chapter 2?
chapter 2,
Uh-huh.
where we were doing this.
Yeah, if the
We
limit...
just use L'Hopital's rule.
Yes, sometimes. Again, remember, it has to
It was
be...
indeterminate.
If it's indeterminate, we could use L'Hopital's
Because I
rule.
remember when we were indeterminate, we had to do a whole bunch of stuff.
That's right, because we hadn't talked about derivatives yet, right? I couldn't teach you L'Hopital's rule if we hadn't done derivatives.
I think we did some algorithms for derivatives, and then you could have done it fast, because we need to know why it works.
Well, that's the whole point, though, right? You got to know the why. Okay, so look, y'all, let's take a look here. Let's first figure out, is this going to be an indeterminate form? If I plug in x equals 0, does anybody know what e to the 0 is? 1. 1 minus 1. Sine of 0 is 0. That's going to be 0 over 0. That's indeterminate. Okay, so now we're going to use L'Hopital's rule. Let's go ahead and do L'Hopital's rule. What is the derivative of e to the x minus 1? It's e to the x, right? And then the derivative of minus 1 is 0, so I'm going to worry about it. Okay. What's the derivative of the sine of 5x?
Why is the derivative of dx from dx?
Because that's what I'll go back later. I'm not going to do it right now. But the derivative of e to the x is still e to the x. Okay. What is the derivative of the sine of 5x? 5 times cosine of 5x, right? Because I have to take the derivative of the angle as well, right? Using the chain rule, so the derivative of sine is cosine, but then you still have to take the derivative of the angle, and the derivative of 5x is 5. Okay, now y'all look, we're going to take the limit as x approaches 0. So e to the 0, y'all, is going to go to 1. Cosine of 0 is 1. And so that's going to give me 1/4. Okay. And guys, I don't know if you noticed this or not, and I don't know why, but there's some people that call it hospitals. Call it Lopital, right? Why? I don't know. I'm sure there's a story. Yeah, I'm sure there's a story somewhere on why it's hospital in some case and why the S is missing on others. It could be.
In French, probably has an S.
It could be. Yeah.
We pronounce it S.
Okay, so look, y'all, let's take a look at this one here. The limit as x approaches 0 of sine of 2x over sine of 10x. First off, if we plug in the 0 immediately, are we going to get an indeterminate form? What's the sine of 0? Anyone know?
Sine of 0, what?
Let's see. Turn this thing on. Sine of 0 is 0, right? Okay. So we do end up with the indeterminate form. Okay, let's go ahead and do it then. What's the derivative of the sine of 2x? There you go, man. You got a big smile underneath this mask right now, y'all. What's the derivative of sine of 10x? 10 cosine of 10x. Very good. Okay, so look, y'all, if I use my calculator, remember, we've already figured out that the cosine of 0 is equal to 1, right? So this is going to be 2 times 1 over 10 times 1, which is 2/10, and that reduces to what? 1 over 5. Okay, so y'all, earlier, John was asking me, why didn't we do this earlier? And I don't know if you remember this or not. You probably don't because it's been a long time. The only reason I remember it because I'm the one who's teaching this and I'm the one who makes the notes, right? So that's the main reason I remember this. But we actually had a problem real similar to this back in somewhere in chapter 2. And the way we did it, I don't know if you remember this or not, but one of the rules that we had established was that the sign, I'm going to use y. If I take the limit as y approaches 0, the sign of y over y was equal to 1. Okay, so what we did back in chapter 2, we said, look, let me put a 2x right here, but then I got to put another 2x right there. Okay, and what we did also back in chapter 2 was, well, look, if I have a 10x right here, let me put a 10x right here, and then I'll put another 10x right here. And then what we said is, look, let's go ahead and drop those x's. And if we're taking the limit as x is approaching 0, isn't that number there going to convert to 1 because of this rule right here, right? And wouldn't the sign of 10x over 10 also convert to 1, right? Because of this limit right here. So then what do we end up with? We would end up with, 2/5, or not 2/5, but 1/5. Sorry. And that's what we'd end up with. That's how we did it back in chapter 2, okay, because of this rule here, okay? But Lopital's rule works as well.
I forgot. Why did we learn the derivatives like that?
Because what is the derivative? It's a limit. I can't explain derivatives if I don't know what limits are. Think about it this way. When you were a kid, how did you learn multiplication? By adding repeatedly, right? If you ever see the original Karate Kid, Mr. Miyagi says, you got to learn how to walk before you run, Daniel-san, right? It's the same kind of concept. All right, look, let's do the same thing here. Okay, if I plug in 0, everybody agreed that we're going to get indeterminate forms? Because the sine of 0 is 0, and the tangent of 0 is also 0. So again, we have that indeterminate form. So let's go ahead and use our derivatives. What is the derivative of sine of 15x? 15 cosine of 15x. Very good. Does anybody know what's the derivative of the tangent of 13x? There you go. Okay. Now we're going to take our limits, y'all. Now we're going to take the limit as x approaches 0. So I know that the limit of cosine of 15x is going to be 1. So that's going to be 15 times 1. Okay. Secant of 13 is also going to be equal to 1. So my answer is just 15 over 13, right? Yo, just to give you a heads up, if you're a little uncertain about this part here, remember that secant can go back up to the top and it'll become a cosine of 13x, right? And now you have that. But the limit is still going to be equal to those ones, right? All right. Okay. Again, we're going to use Lopital's rule again. I want you to notice, y'all, if I plug in x equals 0 on the bottom, I'm going to get what? 0 on the bottom. If I plug in 0 on the top, that's going to become a 1 plus 0 minus 1. So yes, I have my indeterminate form. Okay, let's go through. We're going to go through slowly. The derivative of e to the x is still e to the x. What's the derivative of 3x? 3. And on the bottom, the derivative of 6x? 6. Now let's take the limit as x approaches 0. So as x approaches 0, e to the x approaches 1. So this becomes 4 over 6, which simply reduces to 2/3.
ln is natural log, right?
ln is the natural log. It's the log with the base of e.
Okay. The natural log is e plus 36. That's a good one.
I'm sorry, say that again?
Like back then when I did it on the limit of like the was a function that like gave a rule,
Uh-huh.
it just gave me the natural log of e plus 3/6. Is that still fair?
The natural log of e plus 3/6, right?
Yeah.
Okay, so this is a college algebra problem. Natural log of e is equal to 1.
Well, why did they just give me 3/6?
I don't know. You got to ask Cass. Okay, look, y'all. Same kind of thing here. We're going to use L'Hopital's rule. So number one, it's telling me to use L'Hopital's rule, but I want you to think about this for a minute. Look at the limit we're taking now. We're taking the limit as x approaches infinity. As x gets really, really, really big, do y'all agree e to the x also gets really, really, really big? Think about it this way. I think we did this the other day in class. So look, if I go second, I don't know, I think we were able to do 100. Look how big that number is. 2.68 times 10 to the 43, right? Remember what that means? That means that number is massive, right? And all we've done is plug in 100. So it's like I plugged in a 25 right there, right? So if this number is getting really, really big, but this number is also getting really, really big because x is growing as well, right? So I'm going, yeah, and it's being squared. So look what I'm going. X is getting large on the top. The value on the bottom is going. This is also an indeterminate rule, okay? Hold on, I'll get with you in a second. Let's use L'Hopital's rule. What is the derivative of 8x squared? 16x, very good. So let me write that down here. 16x. Okay, what's the derivative of e to the 4x? Give me a hint. E to the 4x, you got to take the derivative of the exponent. There we go. Okay, now, guys, I'm going to take the limit again as x approaches infinity. Let me ask you a question. Is this still going to get really, really, really big on the bottom? Yeah. Is this still going to get really, really big on the top? Yes, it is. This is still indeterminate. So you know what we do? We do it again. Okay? Let me ask you a question. What's the derivative of 16x? Okay? What is the derivative of 4e to the 4x? I'll give me a hint. There's going to be e to the 4x. And we're going to use that 4, and with the derivative of that one, very good. Another 16, right? Well, hold on. We haven't finished yet. Do you agree with me that 16s are going to cancel? Okay. Now, y'all, if we're taking the limit as x goes to infinity, do you agree that the bottom is getting really, really, really large? The bottom is staying as what, though? I mean, sorry, the top is staying as what, though? 1. 1 divided by a really, really large number approaches what? 1. We had to use L'Hopital's rule twice because even after we did it the first time, that function or that fraction was still indeterminate. So we do it a second time, okay? All right. So look, let's try the next one here, y'all. We're going to evaluate the limit again using L'Hopital's rule. Bye-bye. So as x approaches 0, again, the bottom part is going to go to 0. So is the top. So I have my indeterminate form. We're going to go ahead and start taking the derivative. So I know the derivative of the top should be e to the x minus 1. The derivative of the bottom is going to give me something like, what, at 10x? Okay. If we take the limit as x approaches 0, do y'all agree that we still end up with an indeterminate form? Yeah. So we're going to do L'Hopital's rule again a second time, y'all. So we do L'Hopital's rule again. This becomes e to the x, over 10. we're now taking the limit as x approaches 0. As x approaches 0, what does e to the x approach? 1, 110. There's my answer. What do you think? Is L'Hopital's rule easy to understand? Yeah? A lot better than 4.7? Yeah, a lot better than the word problems. Yeah, word problems, guys, even at the calculus level.
So if we probably look at like stuff that is built on and created something by Indeterminate Form, I can make it faster.
Hopefully, that was the idea, right? Okay, let's take a look here, y'all. Let's try the next one. So look, we're taking the limit as x goes to 0. Remember, cosine of 0 is going to give me 1. So this is going to be 1 minus 1 over 1 minus 1. There's my indeterminate form. Okay, so we're going to do L'Hopital's rule. Let's see. Question, y'all. Let's do this.
How can we write like, do you write like so like as cover back to like say the time of the function?
Yeah, because this is my f of x and this is my g of x. Yeah. So what we're taking now is the limit as x approaches 0, John, of f prime of x over g prime of x. Okay, y'all, what is the derivative of 1?
0.
0. Okay. What about the derivative of a negative cosine of 8x? Yeah. So that's a plus 8 sine of 8x. On the bottom, a 0 plus a 3 sine of 3x, which just leaves me with 8 sine 8x over 3 sine 3x. Okay? If I'm still taking the limit as x approaches 0, this is still going to be in that indeterminate form. So we're going to do L'Hopital's rule a second time. What's the derivative of 8 of sine of 8x? Not negative cosine, but just cosine of 8x. And then we have to take the derivative of the angle, which is an 8, but multiplying by that 8 there gives me a 64, right? And the derivative of sine of 3x is still sine of 3x, but I have to take the derivative of the angle, which is 3, times that 3 there is going to give me a 9. I'll put a sine, it should be a cosine, y'all. Sorry about that. Right here. Okay. And now when we plug in x equals 0, this becomes 1 and this becomes 1. So we just end up with 64 over 9.
We want to find it where we're going to the function equation. What type of function is that function?
Grid function? Periodic function?
Yeah, when the grid function is going to go
Or possibly 0. It's okay to have 0 on the top. What you don't want to do, you don't want to have an indeterminate form, right? But if I would have had, John, if I would have ended up with a 0 over 1, it wouldn't be indeterminate. That would just be 0, right? So I'm not necessarily looking for, it doesn't necessarily have to be a 1. I just don't want an indeterminate form. I don't want either a 0 over 0. I don't want an infinity over infinity or 1 divided by 0. That's right. All right. So, guys, I want to give you all a second to try this one here. And you tell me what you come up with. And we'll check our answer to make sure that we're all coming up with the same thing. So anybody end up with 4 cosine 4x over 6? Which gives us 4 over 6, which reduces to 2/3. There you go.
short and sweet, we love it.
And that was 4.8, y'all. Short and sweet, right? So we came back at 140. So in 26 minutes, we did 4.8. 4.8 is a nice section, right? So that's kind of why I wanted to do the 3 sections this week, y'all, because I knew 4.7 was a little bit of a bigger section, so I wanted to make sure we had enough time to do it. 4.8, Lopital's rule, most people understand it. And I'll tell you this, like, so let me do this real quick, y'all. Let me go ahead and stop recording.